This became the second New England Journal of Medicine publication within 2 years, where the whole field of myocardial perfusion imaging began. And while those images that you see with rest and exercise certainly don't look very clear, very pixelish, but it certainly makes the point that you can identify exercise-induced perfusion defect that's not present at rest, so-called reversible defect, identifying myocardial ischemia. So this is 1973. And by the way, 1973 is when I was graduating from high school, just to kind of give you perspective where I was. 2 years later, Bill Strauss, again, very cleverly said, yeah, potassium 43 doesn't have great imaging characteristics. Maybe I can replace it with thallium chloride, which has the same biological properties, but much more favorable physical properties for imaging with the rectilinear camera. And so you can see from this image in the dog model, it's an occluded LAD. While they both show perfusion defect, the perfusion defects seem much, much better with thallium chloride. Again, 1975, when thallium chloride replaced potassium chloride for detecting coronary artery disease. Now, Jerry Pohost, cardiologist at MGH, also was working in this area and with animal models. And he was the first to describe thallium redistribution. It was an accidental finding, by the way. He was moving the animals to the camera from one building to the other. And by the time they took about an hour or two to move the animals. And when we went ahead to image the heart, there was no defect. And he knew that he had occluded the LAD, and then he realized that during that transport period, there was redistribution phenomenon occurring, and that's how he described redistribution. Now, what's interesting about this slide that I want to share with you, Dr. Akins, which is a co-author on the second paper, is a cardiac surgeon for MGH. So Jerry Pohost was able to convince a cardiac surgeon to take a patient with 15% ejection fraction, New York Heart classification of 4, and as you know, the surgery of CABG wasn't very advanced at the time. And he showed that with planar imaging, that with stress, you can see that there's severe inferior infraapical perfusion defect with lung uptake. And on the redistribution image, he showed that there was reversibility in the inferior region, but fixed defect at the apex. And despite that, he was able to convince Akins to take this patient to surgery. Patient went to surgery, and post-CABG, you can see that not only the reversible defect improved, but so did the fixed defect in the apex. And by the way, this is the first time, although they didn't recognize at the time, is the first example of a patient where EF improved from 15% to 27% at rest. They didn't notice was hibernating myocardium, but certainly the patient felt much better. So where was I? Well, in 1977, which is the same time as thallium redistribution was being developed, I happened to be doing my master's research as a chemical engineer at Tufts. And had no idea I was doing my work with potassium chloride and membrane transport, and didn't realize that what I was doing as a master's thesis student was going to be an important part of my career path in nuclear cardiology, understanding membrane transport of potassium chloride and thallium chloride. Now, we talked about PET and PET-CT. I just want to remind everybody here that it began back in 1950s and 60s. It's not a new technology. Dr. Ter Bogosian, who was a medical physicist, did the early experiments and took advantage of the coincidence detection by PET radiotracers. Now, Dr. Alan Cormack, who was my physics professor while I was a freshman at Tufts in 1973, won the 1979 Nobel Prize in Physiology or Medicine, along with Hounsfield, and for their work for developing X-ray computed tomography. And subsequently, obviously, PET-CT became important to assess biological function as a correlate with anatomical assessment with CT. Dr. Lance Gould, again, this is all in 1970s, by the way. remember, the field just started, and all of these great inventors, scientists, were moving the field forward, convincing our surgeons, our cardiology colleagues, that this is an important field. He was doing some of the early work with coronary flow reserve that we have come to appreciate very well now. He used some of the earliest vasodilator stress studies in animal models. In collaboration with Dr. Shelbert, they won the von Hevesy Prize in 1978 for identifying mild coronary stenosis using N13 ammonia. Here's a young Dr. Shelbert, and working along with ammonia in dog experiments, and some of the curves that I show you there with the blood pool imaging and the time activity curves of blood pool and retention in the myocardium is what we do now with blood pool quantitation and myocardial uptake. They were the first who did the clinical trial, cyclotron-produced N13 ammonia in PET using N13 for detecting coronary artery disease. In 1982,